Okay, so I'm looking at the questions for the week. Thank you for participating in that and asking some questions. That's what this is about. So I'm going to go through as many of these as I can in the amount of time. So let's see, we've got a question about dividing complex numbers in A plus BI form. So let's start off with that. So we want to divide A plus BI form. So let's go ahead and I'll do one of those. 3 plus 4i. We're going to divide that by 1 minus 2i. I'm just making some things up here. So we're going to divide this, and we're not changing it into trig form. We're keeping it in A plus BI form. That's the way I interpreted the question. To do that, you're just going to go like this. You're going to multiply by the conjugate of the bottom. Because I is a square root. You can't have a square root in the bottom. So to fix that, you're going to multiply by the conjugate. Remember, the conjugate is going to change this sign right here from its opposite to its opposite. So since it's a minus, this is going to be a plus. And we're going to do the same thing on the top. All right, so we're going to multiply these. All right, here we go. So let's do the bottom. We're going to get a 1, right? And then what the nice thing about a conjugate, remember, is that you're going to get a plus 2i and a minus 2i, so the I terms are going to go away, leaving us with a negative 4i squared. Remember, I squared is negative 1, so that toggles that negative 4 to a plus 4. So there is the bottom. Now we need to do the top, so we're just going to FOIL that. So we get 3, I get a 6i, I get a 4i, and then I'm going to get an 8i squared. But remember, again, that's a negative 1, so it becomes a negative 8. So we're going to get a negative 5 plus 10i, and this should all be reduced. 5 goes into, I'm going to change this to a different color here. There we go. So this 5 and this 5 and this 5 and this 10. So we're going to have a negative 1 plus 2i, just like that. That is how you divide them in A plus BI form. If you wanted to divide them in trig form, then you would put both the 3 plus 4i and the 1 minus 2i in trig form, and then you would apply de Moivre's theorem sort of in division, all right? So, for example, in fact, somebody asked, well, what about converting? So let's go ahead and convert that, and we'll take a look at those, actually. So let's take 3 plus 4i, and we're going to convert that into trig form, all right? So let's do that. Convert, okay, to trig form. So I'm going to take the 3 plus 4i. So to convert that, I need the r value. I'm basically going to multiply this. Here we go. We're going to get a r value. Oops, I don't know why I put a 5 there. Sorry, folks. There we go. I'm going to put an r value there. Cosine theta plus I sine theta, where theta is measured from the x-axis. All right, so let's do this. So we're going to take 3 and 4 and square them and square root. That's how we did that. It's because you're looking at this graph here of 3 and 4. So this is 3, this is 4. We're after that leg, so that would be a Pythagorean theorem. So 3 and 4, that's an easy one. That's going to be a 3, 4, 5 triangle. So we're just going to go like this. All right, now I need to figure out what the theta is. So I have to use my inverse tangent of the 4 over 3 because it's opposite over adjacent. So then I'm always going to put the imaginary part over the real part. Now I need to figure that out, and my choice on that would be to use Desmos. So I would go here and make sure that this is in degrees, and then go. So I'm going to take the inverse tan of 4 divided by 3. Everything is positive, so I get a 53.1 degrees. 53.1 degrees is what I'm going to put there. Plus, and of course the sine value is the same. All right, and like I just said, since both these values are positive, you really don't need to worry about drawing it out because you're going to get a first quadrant angle in return. So there is that one written in trig form. Now if we do the same thing with this one and we put it into trig form, all right, we'll follow the same steps. So 1 squared and 2 squared, that's 5, but this time we're going to have the square root of 5, bracket, cosine. Okay, I need that theta, so I got negative 2 over 1. I'm going to go back in the decimal, so I'm going to say, hey, I need inverse tan of negative 2 over 1. And I get negative 63. Okay, so let's scooch back to this now. This one, since I do have a negative, I'm going to draw it out. So I'm going to go like this. And let's see, negative 60. So I have a negative 2. So I have a 1 and a negative 2. So it's down there. All right, and it just so happens that since it's down there and my return was a negative 63, then I've got the right angle. So I can either put negative 63 in there, right? Or I can consider the angle from all the way from here, to there. All right, I can consider that one. So it really doesn't matter which one you choose because it's the same angle. I'm going to put the negative 63 in there. Maybe. Let me try this again here. There we go. I think we're going to get it to work this time. So I'm going to put the negative 63 in there. Okay, plus I sine negative 63. Okay, so there's that one. Now somebody was asking about the division, right? A plus bi form. I did that. If you wanted to divide these in trig form, then you would take the first one, 3 plus 4i, and divide it by the second one by taking those two numbers. And so you're going to go like this. So we're going to go 5 divided by the square root of 5. I know we're not going to do it, but hang on. All right, then we're going to subtract the angles. So we would take 53 and subtract 63, but it's negative, so it would be like adding. So we have cosine of 0.1 and a 6 and 160. So there we go. Plus I sine 116.1. Right. So that would be the result of taking these two right here and dividing them. So if I was to say that this one is, we'll say this one is Z, and this one Z1, we'll call this one Z2. So this would be the result of taking Z1 divided by Z2. All right. And we should rationalize this, clean it up a little bit here. So let's go with 5. I don't know why that's happening there, but 5 square roots of 5 over 5. Those are going to go. And we're just simply going to be left with a square root of 5. So we're going to have a square root of 5, bracket, cosine 116.1 plus I sine 116.1. There is Okay, if I divided it. So, I think I kind of covered those questions pretty well there. The next one was, how do I convert into using Wolfram Alpha? All right, so let's go ahead and do the exact thing. And let's take this guy right here, and let's put that into Wolfram Alpha and see if we get the same answer that we did on top when we did the division, right? That'd be a great way to check it out. So we're taking this problem, and I'm basically answering 3 questions for you. So let's go into Wolfram Alpha. All right, so I've got that loaded up already. Here it is. So I just need to type that in. All right, so first of all, I want to multiply. So I'm going to go square root of 5. So I'm going to have to make sure I get this right. Shift 5, shift, there we go. Now I'm going to times that by, parentheses. Okay, I want cosine. And I want 116, man, I just keep not getting the shift. 116.1, okay, plus I, and I think it helps if you put the times in there, times the sine of the same thing, 116.1, shift, close it, and shift, close it. All right, let's see what this does. I'm going to double check and make sure that that's what I had, 116.1, square root of 5, yes it is. Oops, wrong thing, there it is. All right, let's do it. Let's see what it is. So I'm pushing the little equal sign there. All right, and it's got it down here, and it says, I don't know if you can see it, see if I can make it bigger. The result is negative 2.21 plus 0.0309 I. So let's go ahead and check to see if that is correct as far as what I got. So I'm going to go back into here and scroll up and see what I ended up getting. Here I had negative 1 plus 2i. So let's go back to Desmos, or excuse me, in this Wolfram. And is it pretty close to that? It is not very close to that. So now I'm a little concerned about what I've got for an answer here. So let me go back to this. All right, so let's see. I think I did that part correct. I'm going to look down here and see what we did here. Let's see, we had 53 and negative 63. And we had a square root of 5, so we're taking the top divided by the bottom. So that means we're going to divide the 2 roots there. And square root of 5, square root of 5 over 5. That should be right. And I know you subtract them, so unless I screwed up someplace, I'm going to go and add these two. So it'd be 116. I don't know where the issue is on this. Let me find out. I know it's what you do. I know it's what you do. For subtraction is you just do the opposite. So I don't know why is this such an issue here. Yeah, if you divide them, you're not using Demoster. Yeah, it's divided, and it's subtracted. Huh. Okay, so I found the mistake after going over my work countless times here. And all it was going into Wolfram and changing it into degrees. So once I change the setting into degrees, we get negative 0.98 and 2i, which was the answer, was negative 1 plus 2i. So considering the round off. So that was all it was just a simple little changing the thing into degrees. Wouldn't you know it? All right, so I spent a lot of time actually looking at that. All right, so there is how you would divide a complex number in A plus BI form, also how to divide a complex number in trig form, and how to change from complex to trig form, and how to use Wolfram alpha for complex numbers. Let me go back and show you that form again. So all I did was just go square root of 5, parentheses, because it knows to multiply, cosine, and the angle. Just got to make sure it's in degrees, because mine wasn't. And then, excuse me, that will give you the answer. Here it is in the trig form. I don't know if you can see that right there. And then this is what it is in A plus BI form. All right, so let me see what the next couple of questions are here. Let's see. Theta, how does theta change? I'm not exactly sure what you're asking there. Theta, how does theta change? Well, it depends, right? If you're multiplying them, then let's just say that we're multiplying. Okay, so if we're going to multiply two complex numbers in trig form, so for example, if we have this one, I'm just going to call this R1, and cosine of theta plus I sine theta, and this one is Z2 equals R2, whatever that is. All right, cosine, we'll go alpha plus I sine alpha plus this. Then if you want to multiply those, you're going to multiply the R values, R1 times R2, and then add the angles. All right, so then that would become a theta plus whatever the heck that is, right? Okay, so, and then of course you do the same thing on this side. So, yeah, that's how the theta would change if you multiply them. If you divide them, you're going to subtract. If you raise them to a power, you multiply. That's what Demosthenes theorem says. So I'm not exactly sure what you mean about the theta part. How would you use this in a real life situation? Well, that's a good question, right? And, the cool thing to me about this is that you can find those complex roots, right? And that's kind of neat because that's something that you haven't really talked about before. And to think that you could put this into a coordinate system and visually see what's going on with finding those roots, I think that's kind of cool. How they would use that, again, I'm not exactly sure. It might build into, I don't remember it building into anything in calculus, but that was back in the 1980s when the technology was just really getting going. So there could be some more things that they're using that kind of stuff for now, since the technology opens up more doors. So I don't really have a real answer for that one. And then another question was just converting it again into trig form. So hopefully this kind of helped you. And we answered your questions. Again, I just encourage you to put your questions in there. It doesn't matter what they are. I tried to create it so that it was a non-threatening document. You could put your questions in and put your name by it or anything. It didn't matter. Ask anything. It doesn't matter what you put in there. So you're going to get a quiz, right? And again, remember that you are going to give me a video on that. All right. So you want to present it on paper or write it on paper, and then you could just video your explanation. You could do that. or you can just video your explanation as you're working through the problem. I need to see the problem and I need to hear your explanation. And someplace on that paper, or just mention your name, because I notice sometimes it doesn't tell me who they are and I have to kind of figure it out. So it's helpful if you just tell me who this is I'm listening to. Other than that, I think that's about it. Next week we'll move on to the next topic, and I'm going to figure that out because there are some things changing again, so we're just simply running out of time. And so I need to figure out what would be best. So have a great weekend, and I hope this helps.